All right, so back to this class data one more time. We're still looking for different ways to describe what a typical or average member of the class is like with regard to their responses to those three questions. So the first question, have you ever been in a physical fight? This is a nominal level question. We don't have numerical data, so all of our answers are yeses and nos. This means that we can't find the mean. The next question, how afraid are you of being victimized, is ordinal. So all of our responses to this question are in words, and we can put them in order from least to most, but it's not numerical data again. So we can't find the mean. So the mean, as I said, is only appropriate for interval or ratio level data. This means that we can find the mean for our last question here, which is how many times have you been stopped by the police in the last 3 years? And so to find the mean value for this question, what you would do is you would add up all of the numbers of times every member in the class has been stopped by the police and divide by 52, which is the total number of responses we have for this question. If you do that, you get a mean of 1.62 stops. And I'll just ask you to take my word for that. But what you can see here is that our mean value is a little bit different than our mode and our median were. So the mean is reflecting more than just either the most common value or the middle value. And so a nice thing about the mean is that it uses all of the information that's in the data. So with the mode and the median, you could change out some of the values in certain places and it wouldn't change your mode or median. But with the mean, you're including every single value in your mean calculation because by definition, you're adding them all in together. So your mean is sensitive to every single value in the data, and it's using all of that information. And because of that, the mean is often considered the best measure of central tendency to use. Because unlike the mode, where you're really only paying attention to one value, and unlike the median, where you're paying attention to what's in the middle, but you don't really care what's out on the edges, with the mean, you're using all the data. So it's giving you the most information that you possibly could have about what a typical value is like. Now, this is usually a good thing, and so most of the time, if you're reading a paper for a class or you're doing anything else, you're going to see mean values reported when somebody wants to summarize what a typical or average case is like. But there are some situations where you don't want to use the mean, and that's what I'm going to talk about next. So the mean is sensitive to every value in the data, and it uses every value that there is in your data. The downside to this is that the mean is sensitive to large values. And what this means is that large values can pull the mean away from where the rest of the data is because they're getting added up in there too. And as an example, I'm going to show you the frequencies for the question about how many times a month you smoke marijuana. And this is actually from last semester's class because somebody in the class decided to be hilarious and tell me that they smoked weed 420 times per month. So obviously this is a very extreme value compared to the rest of the responses in the class. And I'll also just take a moment to note here quickly. I've taught this class at Rutgers. I've also taught this up in Albany in upstate New York, and either they're smoking way more weed than you guys are, or you guys are holding out on me, because it's always like so many people just, say 0 here. And I suspect I'll never know the answer to that question. But either way, this is the frequency distribution that we have for the amount of weed smoked by people in last semester's data analysis class. If you calculate measures of central tendency for this question, you get a mode of 0 times, so you can see just by eyeballing it there that 0 is by far the most common response. So most people just aren't smoking at all. The median is also 0 times. So if you list out these 42 responses in order from least to most, your middle value is 0. But your mean is 12.02. So what you're seeing here is that you have a mean that's much, much different from your mode and your median. And it's much, much larger. The reason for this is that when you add up all of these values, that single value of 420 is so big that it kind of inflates the whole mean and makes it much bigger than it actually is because it's such an extreme value. And so when you're adding all your values up and dividing by 42, you get an average that seems really, really big. And this becomes an issue when your mean doesn't really accurately represent what's going on in the data. So here, if you were to only look at the mean, I'd be saying that the average student in my data analysis class last semester was smoking weed 12 times a month. But if you look at the data, that's a really inaccurate statement, because really we have 34 of the 42 people who aren't smoking it at all, and everybody else is smoking it much less frequently. So here, your mean is not a great measure of central tendency because it's being sort of pulled outwards by this really extreme value that we have. Here's the same data, but with that one value removed. So we're going to take out 420 from our frequency distribution and calculate all these values again. So what you can see here is that we have a dramatically different set of measures of central tendency, at least when we look at the mean. So our mode and median are the same. Neither of those was affected at all by that really extreme value we had. And this is getting at what I was saying on the last slide, which is that mode and median are not using all the information in the data. So sometimes it's possible to change it around a little bit or switch something out, you know, if there's one value that's unusual, and it's not going to change your mode, it's not going to change your median. As you can see, 0 is still by far the most common response here. And if you were to list out these 41 answers in order, your middle value would still be a 0. So mode and median are relatively robust when it comes to extreme values like that. So, you know, a couple of values that are just much different than everything else. And here, when we don't have this really extreme value in, our mean has gone from 12 times a month to 2 times a month. So it's much, much closer to what you might think of as sort of an average or typical number of times weed smoked per month. But it's still bigger than the mode and median. So let's take a little look at what's going on there. So more specifically, what we're seeing in the last couple of examples is how the shape of a distribution can affect measures of central tendency. And specifically, whether a distribution is left skewed or right skewed affects where measures of central tendency may fall. So specifically, if a distribution is symmetrical, so if it's shaped like a big hump and doesn't have any particular skew to one side or the other, the mean tends to be in about the same place as the median. So both of them will fall in the center of that big hump, and they'll both be accurate measures of central tendency. If your distribution is skewed left or right, however, your mean and median start to separate. And what happens if you have a left skewed distribution, so a distribution where most of your data is on the right side of the graph with a tail pointing out towards the left, your mean is going to get pulled out towards that left side. And so it'll be less than the median. And for all these, I'll show you actual graphs in a moment. If your distribution is right skewed, so if most of your data is on the left side of the graph with a long tail pointing out towards the right, your mean is going to get pointed out towards your right. And this means that it'll be pulled out in a positive direction, and it'll end up being bigger than the median. And the more skewed your data is, the further apart the mean and median are going to be, because the mean is going to get pulled farther and farther out towards the extreme values that are in the end of that tail on your graph. And so that's what we saw with the how many times do you smoke weed per month questions, where when we had a really extreme value that would be really, really far out on one end of the graph, the mean got pulled really far away from the median. So here's what that looks like using some examples from the class data. So one of the questions I asked you guys was, how likely do you think it is that you're going to get an A in this class? And this was a left skewed distribution. So as you can see, most of the responses are on the right side of the graph, so most people feel pretty confident that they're going to leave this class with an A. And then as you go out towards the left side of the graph, so towards lower values, you have fewer people who are feeling a little bit less confident about this class. And if you were to calculate the mean and median for the responses people gave, it looks like this. You have a median value of 85. So half the class thinks that they're going to do better than 85% in the class. Sorry, half the class thinks that there's an 85% chance they'll get an A or higher. Half the class thinks that there's an 85% chance that they'll get an A or lower. So 85 is the middle value if you list out how certain everybody is that they're going to get an A in the class. So again, half the class is at 85 or higher, and half the class is lower than that 85 in terms of how likely they think that it is that they'll get an A. The mean, though, is 80. So if you add up everybody's certainty values and divide by the total number of people who answered the question, you get a mean of 80. And what's happening here is that your mean is smaller than your median because it's getting pulled out towards the left by the people who are feeling more uncertain about the class. So the mean makes it seem like, on average, a student is less certain about the class than the median makes it seem like. So here, in thinking about what a typical student is like, your mean is going to be affected by those more extreme values that are on the left side. So people whose certainty is farther away from what most people are saying in terms of certainty. So we also have the graph for the number of times that students in this class said that they've been stopped by the police in the last 3 years. So this is a histogram for the same data that we've been looking at on all the other slides to look at measures of central tendency. And what you can see when this is graphed is that it's a right-skewed graph. So in other words, most of the responses are towards the left side of the graph, so it's people who have been stopped relatively infrequently. And then we have fewer people who've been stopped more times, which is what you see in that sort of lower tail that goes out towards the right side of the graph. And this right skew is reflected in the mean and median. So what you have here is a median of 1 and a mean of 1.6, which we already calculated. And what this tells us is that, again, the middle value in the distribution, if you were to put all of these in order, so all the numbers of times people have been stopped in order from least to most, the middle value is going to be 1 stop. And we can find the mean by, again, adding up the numbers of stops that everybody has and dividing by the total number of people who answered the question, and that gives us a value of 1.6. So we have a mean that's larger than a median. And again, what's happening here is that because the mean includes the larger numbers that sort of represent fewer people in the class, it gets pulled out towards the right side of the graph. So it becomes a higher value than the median. You can also see this in the really, really dramatic right-skewed distribution that we have for number of times my last class smoked marijuana a month, if you believe whoever said they smoked it 420 times a month. And so for a really extremely right-skewed graph, where you have the vast, vast majority of your data clumped on one side of the graph here, which is on the left side, and then one really, really, really extreme value out on the right side, you have a mean and median that are really, really far apart, because the mean has been pulled out from the rest of the data by that really extreme value. So here we have our median of 0, which is a pretty good representation of how often data analysis students smoke weed, and then a mean of 12, which is not a great representation of how often data analysis students smoke weed, because it's been pulled out to the right side of the graph by that one value. And I also just love to think about the fact that whoever put 420 in there, you know, they were just making a joke and they had no idea that I was going to take this and run with it for multiple semesters. So, you know, thanks to that person for giving me this great example. All right, so in thinking about averages, one thing you want to look out for are reports of averages or typical cases that use the mean when you have a really skewed distribution, because it ends up being inaccurate. Just like it would be inaccurate to say that the average data analysis student smokes weed 12 times a month, when the vast, vast majority of students are not smoking weed at all. And so this is a real headline pulled from a CNN story, which said that some savings measures show that households are flush, but consumers are spending every dime they make. And specifically, this CNN article reported that the average US household has a net worth of greater than $400,000. But Americans are saving 0% of their income. And so the implication here is that the average American household is spending $400,000 a year, which is kind of crazy. But what's really going on is that this story is reporting on a mean when they're looking at a really skewed distribution. And so the answer to this question, does the typical US household spend $400,000 a year, is a big no. And what's really going on is that while you have a mean net worth of around $400,000, so they even rounded to make it more dramatic in the article, the median household income was about $86,000. So what was going on here? Well, you have a really skewed distribution, kind of like that how many times do you smoke weed a month graph that I just showed you. And what you have are most people clumped on the left side, making a modest amount of money per year, modest amount of household income. And then you have, going out towards the right, your people who make a lot of money. Your millionaires, your billionaires, your super mega Jeff Bezos bajillionaires. And they're all thrown into that average too. So because you have a distribution that's extremely skewed, where most of your data is clumped on one side of the graph, and then a little bit of your data is kind of pulled out there on the tail, you have a mean value that's not actually representative of a typical case in your sample. So in the United States, a typical person doesn't make $400,000 a year, even though that's the average. And instead, that average is being pulled out by extreme values that are much larger than everything else. So the last thing I'm going to talk about here is which measure of central tendency is the best one to use. And the answer to this question is going to be different depending on the data that you have. So I have it summarized here in a table, and I'm just going to talk briefly about what this means. So the first thing to consider is your level of measurement. For some types of variables, you're limited in the measures of central tendency you can use. So if you have nominal level data, so you have attributes of your variable that can't be put in order from least to most, you're stuck with using the mode. Because you can't put everything in order and find the middle, and you can't add everything together and divide by your number of responses. So you're stuck with using the mode, which will just tell you what was the most common category or attribute that there was. And so that's the case for the median also, or for ordinal data also. If you have ordinal data, you can find the mode, you can find the median, but you can't find the mean. The next thing to consider is how much information the measure gives you. And as a general rule, more information is better. And as I talked about a little bit throughout the rest of the lecture, these measures of central tendency differ in how much of the information in the data set that they use. So the mean uses all the data. It uses every single observation that you have in your data. So it gives you a lot of information. The median uses some of the data, but for a lot of it, it's only telling you sort of what's bigger and what's smaller, and the actual values of anything that's bigger or smaller than the median don't matter that much. So we say that it's giving you some information about what's going on in the data, but it's ignoring some of what's going on as well. The mode is, again, based on one single observation that happens to occur a lot, and nothing else in the data matters. So we say that it gives you very little information. So as a general rule, if you're deciding which measure of central tendency to use, you want to use a measure of central tendency that gives you more information. So in typical cases, the mean is better than the median, and the median is better than the mode, as long as you can use it for the level of measurement you're working with. Your final consideration, though, is whether there are extreme values in the data. So if you have a data set that's very skewed, so it has some values that are much larger or much smaller than sort of the bulk of the rest of your data, the mean becomes inaccurate, like we just saw in the last couple of examples, where the mean gets pulled out towards the left or towards the right on your distribution, and it becomes much larger or much smaller than an actual typical case in your data. So if you're using numerical data and it's skewed, your median is going to generally be a better measure of central tendency than the mean, because the median is not going to be affected by those really extreme values. All right, so that's all I got on that. I will just end this lecture with a couple of the usual reminders. So problem set 3 will be due on Sunday, Valentine's Day. Everybody's favorite thing to do on Valentine's Day, math homework, at 11:59 p.m. The optional review session, as usual, will be from 2:30 to 3:30 on Wednesday, so feel free to pop in if you have any questions. If not, also feel free to email me with your questions. I can answer them directly, or if you want to set up a time to do a video review, that's also fine. And then finally, I like that people have been using the option to comment on Canvas. I think that's awesome because then I can respond to you right there and everybody can see it. So if you have any questions, also feel free to comment somewhere on Canvas on any of the announcements or, you know, wherever else it'll be seen. So that's all I got for you guys, and have a great week.